All right, 2-3, day 2, we're going to continue to work on that weighted mean because they can get a little bit tricky. So we're going to do a couple practice problems to start with before we cover the new material. So we'll go back over weighted mean. And remember, it's just the sum of each category's average, so the category mean, multiplied by its corresponding weight. What fraction or what percent of the total grade is the weight? So see the weight as a fraction or a percent. Percent, that's your weight. And then you divide by the sum of the weights. And you saw yesterday that usually everybody has their weights add up to 100%. All right, so here we go. Let's take a college rent and comp class. And let's look at the roster. In this class, there are 6 engineers. And we're looking at their scores on a writing assignment. These 6 engineers had an average of 88% on their, so all together, all 6 averaged together came up 88% on for their average score. We have 5 business majors. Their average was a 70%. 10 math majors. Their average score was 94%. And we have 5 biology majors. And their average score on this assignment was an 85%. And what we want to do is estimate the class average, because we don't know what each individual score was for these 6 people or these 5 people or these 10, but we have their overall averages. So I'm going to look at the wrong way to do that. A lot of people see this, oh, I'm just going to average up these 4 values. So it's healthy sometimes to look at the wrong way. So the wrong thing to do, because people want to do it, is just average up those 4 scores. 88 plus 70 plus 94 plus 85 divided by 4, because I have 4 values. But you got to realize we've got weighting here. 10 of these people had a 94 average. 5 of them had a 70, so there's some weighting by the number of people in the class. So we've got to incorporate that weighting. Okay, an old school way to do it, without weighting, is to think, boy, I've got 6 people that got 88, so that's 6 sets of 88, 5 people that got 70, 10 that got 94, and 5 that got 85. So overall, in order for me to get the class average, I'd have to divide by how many values I have, which is how big the class is, and there's 26 people in this class. 10, 20, 26. So the old school way to do it would be to add up 6 88s. So to do that quickly, it's just 6 times 88. Add up 5 70s. So the quick way would be 5 times 70. Add up 10 94s, so 10 times 94. And then add up 5 85s. So I would have all 26 scores added up, and I would divide by 26. And I've already taken the time to type that in a calculator. You would need parentheses around the top. And you get 86.27 is the class average. Now we can also do it with the weighted mean. So old school works and weighted mean works. Weighted is our category average. So if we look at those engineers, their average was 88. And I told you to think of the weight as either a fraction or a percent. Well, what fraction or percent of the class are the engineers? Well, they are 6 people out of 26. So you would multiply by that weight. Then you add on the next one. The average was 70 for the category for business majors. The business majors make up 5 out of 26, 5/26 of the class. And then 94%, weighting 10 out of 26. Plus, and then the last group was an 85 times 5 out of 26 again. In my weights, I used all 26 out of 26, so again, I'd be dividing by 1, so I'm not even going to bother with that. And believe me or not, but if you type that in just like I have it, you will get the exact same score you have here with the old school way. No difference. Okay, most people can figure that one out. This next one, which it was going to impact you soon enough when you go to college and your college GPA. Little different than high school GPA. Because here, every class counts for the same amount. Where in college, your classes are weighted based on how many credits the class is. So let's look at a typical first semester. Let's say you take Calc 1, which in some classes, some colleges it's 5 credits, others it's 4. We're going to go with the 5 credit college. Intro to Psych. Here, some classes it's 3, or some colleges it's 3, some colleges it's 4. Rhet and Comp. We'll go 4 credits, and then we'll go bowling. Some colleges still make you take those PE credits, and we'll make that a 2 credit class. Okay, see what kind of semester you had. Okay, you're smart. We're going to give you an A in Calc, a B plus in Psych, a B in Rhet and Comp, and an A minus in bowling. So we know it's out of a 4-point scale, so we get the point total to represent each one of these letters. So our A, 4.0, a B plus, 3.33, repeating. A B is a 3. An A minus is a 3.666, repeating. They all subtract by 1/3 each time. Okay, so your semester was 8, 10, 15 credit semester. So, the wrong way to find your semester average would be to just say, well, I got an A, I got a B plus, a B, and an A minus. Add all 4 of those up and divide by 4. Totally wrong. Where in high school that would work, because all that does work, because all of our classes count the same amount. But in college, it's based on the credit. So this bowling class does not have nearly as much impact on your GPA as this Calc class did. So, the weighted way to do this. So our average for Calc was a 4, multiplied by its weight. Its weight is 5 credits. Remember, weight is a fraction or a percent. So what fraction of your semester was calculus? Well, it was 5 out of 15, or 1/3 of my total credits. Then the average for the Intro to Psych was 3.33. And its weight was 4 out of 15. And you keep going. The 3.0B was 4 out of the 15 credits. And then the 3.66, 2 out of 15. And if you type that all in correctly, you come up with a 3.5 GPA for the semester. Okay, the old school way to do it. Well, I see 15 credits, so I want 15 numbers that I'm going to add so I can divide by 15. Well, what are my 15 values? Well, I think of this as 5 4.0s, 4 3.33s, 4 3s, and 2 of these 3.666s. So it would be 4 times 5 plus 3.333 times the 4, plus the 3 for the B times the 4 credits, and then the 3.66 times the 2. That's going to total up the 15 letter grades and divide by 15. And again, old school and weighted both give you the same amount. So whichever your brain wraps around better, that's the technique you use. All right, now some new stuff. Okay. What we're going to do now is find the mean of a frequency distribution. Okay, the mean of a frequency distribution will be an estimate, and you'll see why in a minute. Of the actual mean. So the example we're going to do is coming out of the book, where we are going to be looking at the heights in inches of 16 female students in a physical education class. And their frequency distribution, what they're showing us from 60 to 62 inches, there's 3 girls there that are in that range, 4 girls in the 63 to 65, 7 girls in the 66 to 68, and 2 girls in the 69 to 71. So, we're going to copy that down real quick. So the height and the frequency, so we had 60 to 62, that's a class width of 60, 61, 62, that's a class width of 3, remember, just to refresh your memory. 63 to 65, 66 to 68, and 69 to 71, and it's 3, 4, 7, and 2. Now the reason that this average, I'm asking you, find the average height of this class of girls. The reason it's an average or an estimate is because I don't know the 16 individual heights. I don't know exactly how tall these 3 girls were. Maybe they were all 60, 61, maybe I had a 60 and 2 62s. I don't know exactly what their heights were. So that's why we call it an estimate. And an estimate doesn't mean, oh, just look at it and grab a number. There's a process we're going to go through. So think about it. If I know I've got 3 girls in this range, what would be my best estimate for these 3 girls? Well, if you think about it, we're probably just going to use the midpoint, and we are going to use the midpoint. So I'm going to put that midpoint column in. And I'm going to assume I've got 3 girls that are 61 inches tall. Then I'm going to assume I've got 4 girls that are at the midpoint of 64. Remember, the class width was 3, so these are going to be 3 apart. 67 and 70. So now, making that assumption, I can do it old school or I can do it weighted. Old school says you're going to add up 16 different numbers as quickly as you can. So old school, you're going to multiply your frequency times your midpoint add all that up. Not that I've done this, so I'll take a quick second here. 3 times 61 plus 4 times 64, 7 times 67, and 2 times 70. So when I add up all 16 girls, I've got 1,048 inches. And now to turn that into an average, I just divide that by my 16 girls. So the average height is about 65.5 inches as my best estimate. Because again, these are not the actual heights of all my people. So, there we go. Old school or weighting would be 61 times 3 over 16, 64 times 4 over 16, 67 times 7 over 16, and times the fraction. Okay, next. Okay, we're going to be making some graphs on the calculator. You just made a bunch of graphs by hand. I'm going to show you the calculator does make nice histograms. So I'm going to show you that. And then you're going to have to tell me what shape the histogram is in. So the shape of a frequency distribution. Okay. There's 4 shapes. If your mean, median, and mode are all very close together. They don't have to be exactly the same thing, but if they're all really, really, really close, you will get this shape. Doesn't have to be perfect, but it's high in the middle and it slopes down on each side, pretty symmetrical. And when that happens, the shape is called symmetrical. So when your mean, median, and mode are all pretty close to the same thing, you get symmetrical. The next one. If your bars are all approximately the same height, they don't have to be perfect, but you have no big drops anywhere. Okay? Here, notice we don't have one bar that's way taller than all the rest. That means we have no mode. So if you have no mode, and your mean and median are pretty close to the same value, you get this shape here. And really, when you try to draw a smooth curve through it, it's kind of rectangular. It's called uniform. That's a uniform distribution. And then 2 more. Made that a little big. So here, a tall bar here, a little bit shorter here, and then they start to drop off quickly, so that they get very short over here. If you were to try to draw a smooth curve through that, you get this, comes up, and then it tails off this way. Gets real low. Here you can see our mode is here. It's the tallest one, the most often. And remember, when it tails off to the right here, maybe you're not going to remember, your mean is going to be out in the tail, because these small numbers are going to pull the average away from the mode. So the mean will be out here in the tail, and your median is still going to be somewhere in the middle here. So when it tails off to the right like this, that's called skewed right. Or it might be called positively skewed. So it's where the tail is at. The tail is to the right, so it's called skewed right. So the average got pulled to the right. Okay, and then the other side of the coin, I think you know what's coming. Here, our mode is going to be, a really tall bar is going to be down here. You might have another bar or two after it that's a little lower, but on the start, they're all really low. So here the graph starts low, and then most of your data ends up down here to the right on the x-axis. So again, our mode is going to be way out here. It's going to have a high x value, because remember the x values are increasing as you go out here. The mean is going to be down here in the tail. It's going to have a low x value. And the median is going to be in the middle. Again, this is because the tail is to the left, it's called skewed left. Or negatively skewed. Okay, so the last thing we're going to do is I'm going to make a frequency distribution, guess what shape it's going to have before we even graph it, and then I'm going to show you how to have the calculator make the graph. So the data I'm going to use is in your book, and I'm just going to show it to you real quick. We are going to be looking at the number of days 20 patients remain hospitalized, and they want 6 classes, so that means our graph is going to have 6 bars. I've already put these into a list and sorted them, so I have them, and I'm ready to make my frequency distribution, which is the 2-column table. So number 4. This was the days hospitalized. So stat, edit. I already put them in. The least number of days was 3, and the highest I think was 14. Yes, 14. So the first thing we're going to do is calculate our class width for 6 classes. So remember, it's max minus min divided by number of classes, and again we always round up. So that's going to be 11 divided by 6 is 1.8, which is going to give us a class width of 2. So making our frequency distribution, so the least was 3. Class width is 2, so I want 2 values in here. That means 3 and 4. Start at 3, end at 4. Kind of an easy one. 5 and 6 are here. 7 and 8. 9 and 10. 11 and 12. 13 and 14. And now the frequencies. Remember, all you've got to do, I did sort them already. So the 3s and 4s, whoops, I see 3 of them. 5s and 6s, I counted 8. 7 and 8s, there were 4, then 2, 2, and 1. Okay, before I show you how to have the calculator make this graph, just by looking at these numbers, can you tell me what shape this is going to have? So all you got to do is really visualize. See a bar with a height of 3, then a bar with a height of 8, 4, 2, 2, 1. So I see it starting and then shrinking down. It should, my guess, is skewed right. But we do want to take a look at the graph real quick, because these are handy for making graphs. So you are going to go under, and I'll put the buttons down here so you can look back when you actually do these. You're going to go under Stat Plot. And if you look, that's right above your y equals. I'll zoom that in a little bit. Okay, so right above your y equals is Stat Plot. So I'm going to go second Stat Plot. There are 3 graphs that you can make at a time. So you're going to go into number 1. You want to turn it on. So you hit enter on the on. There are 6 different kinds of statistical graphs it can make. These are scatter plots, some box and whiskers that are coming. I think these are connected line, but here's our histogram right here. So I'll come down, go over, hit enter on that to select it. Tell it which X list, where are your data values at? Mine are in list 1, and the frequency is always going to be 1 for now. So after you do all that, get that all set up, you're going to go to the zoom, and this has a nice feature where it will look at the numbers in the graph and set up a decent window for it. So we'll go to Stat Plot, set everything up, then go to Zoom, and in your Zoom, you want to go down to the one that's Zoom Stat. I don't remember what number it is. On this calculator, it's number 9, Zoom Stat. hit enter, and it makes a nice histogram. But is this the histogram that we wanted with the 6 bars? 1, 2, 3, 4, got a space, and then remember all our bars are supposed to touch. So the way to get it to make it match what we wanted, you're going to go into Window, which is right here, Window, second key in. The only thing you've got to do is change this line here where it says X scale. You want that to be our class width of 2. Change that to 2. Graph again, and that's exactly the graph you would have had if you had just done it by hand. So Window, that move was change X scale, set that to your W value, your class width. And then if you trace, you can see they're telling me the minimum value of 3 and then under 5, because remember we went 3 to 4, but then it tells me how many are in there. There's 3 there, and if you arrow over you can see there's 8 in the next one, 4, 2, 2, and 1. So it matches perfectly. So just going to make a quick little sketch. I'm not even going to bother with numbers because the calculator made the exact graph for me. Just a rough sketch. Good enough. And my guess was right on the start. Okay, that's all I have.